Hello, my name is Carter Folk, and today I'm going to teach you about noise and its relation to industrial hygiene, and I'm also going to teach you how to use a noise dosimeter. Noise is measured in units of sound pressure called decibels using A-weighted sound levels, or it's pronounced dBA. The A-weighted sound levels closely match the perception of loudness by the human ear and by human speech. Decibels are measured on a logarithmic scale, which means that a small change in the number of decibels results in a huge change in the noise and potential damage to a person's hearing. OSHA sets legal limits on noise exposure in the workplace. These limits are based on a worker's time-weighted average over an 8-hour day. With noise, OSHA's permissible exposure limit, or PEL, is 90 decibels for all workers for an 8-hour day. The National Institute for Occupational Safety and Health, or NIOSH, has recommended that all worker exposures to noise should be controlled below a level of 85 decibels for 8 hours to minimize occupational noise-induced hearing loss. NIOSH has found that significant noise-induced hearing loss occurs at the exposure levels equivalent to OSHA's PEL, permissible exposure limit, based on updated information obtained from literature reviews. And now I'm going to teach you how to use a noise dosimeter. So right here we have the X-Tech Land Dosimeter Model SL400. This is just a picture of it. It's right here. This is the calibration device. It's called an X-Tech Sound Level Calibrator. The purpose of a calibration device is to set the noise dosimeter to a known standard, so we can ensure that the noise dosimeter is measuring an accurate and precise sound level. Merriam-Webster's definition of calibration is to standardize something such as measuring an instrument by determining the deviation from a standard so as to ascertain the proper correction factors. And now I'm going to demonstrate how to calibrate the X-Tech Land Dosimeter Model SL400. This is the calibration device right here. I'm going to attach the probe to the dosimeter. I'm going to remove the sound noise cover. I'm going to turn the instrument on, and before collecting samples, you always want to write down what the calibration device, what was recorded on the device, both before and after you conduct sampling. So this calibration device has two different calibration noise levels. One is 94 decibels and the other is 114 decibels. What I have done with my noise dosimeter is I use 94 decibels for calibration because that's typically closest to levels that you're going to be sampling for in an industrial setting. 114 decibels is pretty loud on the dBA scale. What I'm going to do now is I have my noise dosimeter turned on and I have the probe on and I have it set to where it's recording the decibels. As you can see, once I talk into it, the numbers on the noise dosimeter go up. So now I'm going to turn this on. I'm going to insert the probe. The instrument is reading 94.1 decibels as opposed to the calibration device. It should be 94. So now I'm going to write down what the noise dosimeter read for the calibration device, and that was 93.7 decibels. Now that I've calibrated my instrument, I'm going to go and collect samples. When collecting samples over a long or even a short period of time, you want to make sure that the instrument that's measuring the noise is attached close to your ear, because that's where you're going to be hearing noise at, and you want to make sure that nothing is covering the instrument to prevent it from making false readings. Now I'm going to demonstrate putting the instrument on properly. So I'm just going to attach it right here, and then I'm going to put it right here, and now we're going to go and collect some samples. So now that we've completed our sampling, I'm going to press pause for recording on the noise dosimeter. Once I've pressed pause, I can plug this instrument into a computer and collect all of the data on an Excel document. So now that I have completed my sampling, I'm going to calibrate my device one more time. We're not going to do that in the video because we just showed you the first calibration. So in noise dosimetry, there's primarily two different sampling methods employed. One is grab sampling and the other is composite sampling. Grab sampling reflects performance only at the point of time that the sample was collected. So that would be just getting a single reading, specifically in an area. Grab sampling helps determine potential areas of risk for workers being exposed to high levels of noise, which can cause hearing damage. So collecting grab samples can help you determine where you might need to collect composite samples. And composite sampling consists of a collection of numerous individual discrete samples. So this instrument, for instance, can collect samples every 10 to 15 to 20 seconds. So that would be like a worker wearing the dosimeter all day, doing their job. They're typically going to be restricted to a single area. So that would be an example of a composite sample. Now you have all the information you need to conduct your own noise dosimetry test.